Hello everyone, this is your Cloud Pilot Udesh and welcome to Google Cloud Associate Cloud Engineering course. In this course, you will be learning about how to pass Google Cloud Associate Cloud Engineering exam. You will be prepared to get certified on GCP Associate Cloud Engineering exam. This course will also give you some foundational knowledge on Google Cloud Platform and how to choose Google Cloud components following the best practices. Welcome to the course, and I'm wishing you all the best. There aren't any prerequisites for taking this course. Ideally, if you have some fundamental knowledge on cloud computing and if you have any work experience on any cloud service providers, this course will be very easy for you. And this course is intended for anybody who wants to get certified on Google Cloud Associate Cloud Engineering certification. And now let's talk about what the exam is. What is Google Cloud Associate Cloud Engineering exam? So, it is basically a certification exam, which is more like an assessment that will test your ability on how you can set up a cloud solutions environment, how you can plan and configure a cloud solution, how you deploy and implement a solution, how you can ensure successful operation of a cloud solution, and how you would configure the access and security. To know more about the exam, I definitely recommend visiting the Google Cloud Associate Cloud Engineering certification page provided by Google. Now let's talk about the exam. The duration of the exam is 2 hours. The price is $125 exclusive of tax, but if you're in India, you will also get a 40% discount. There are 3 languages supported, which is English, Japanese, and Spanish. The exam format has actually two types, which is multiple choice and multiple select questions. On multiple choice, you select either one correct answer, but on multiple select, you will have to choose multiple correct answers. There are two types of exam methods available. One is an on site proctored, and the other is a remote proctored. On the on site, you go to a test center and then take the exam. If you are choosing remote, you can take the exam within your comfort within your home. There are no prerequisites for the exam, but if you have some experience on the Google Cloud, then that will be a good advantage. Now let's talk about the contents that we are going to cover in this course. So in this course, we will be covering the introduction to Google Cloud, the Google Cloud Platform services, the resource management inside Google Cloud, the identity and access management, which also stands for IAM. We'll also discuss about networking, and we'll also see how we can manage the networks. Then we will also discuss about the computing resources, under which we have Compute Engine, Kubernetes Engine, App Engine, Cloud Functions, and Cloud Run. Then we'll also discuss about storage, where we'll also do some demos on storage and data transfer. Not just that, we will also look into application deployment, monitoring, logging, and debugging. We'll also cover one of the most important topics, which is cost estimation. As an architect, it is definitely important to see the cost estimation. So we will also cover in this course. And in the end, we will also give a strategy to prepare for the exam. Now, let's start with the introduction to Google Cloud. Before we move in to know more about Google Cloud, we should first know about the service model which a cloud provides. So basically, you can consider four types. One is on premises or the traditional data center. So, in an on premise environment, you manage everything, including your applications, data, runtime, middleware, operating system, virtualization, servers, storage, and networking. So, at a point, a service provider came in and told you, we will manage virtualization, servers, storage, and networking. And you just have to manage application, data, runtime, middleware, and OS. And that was how infrastructure as a service came into existence. So you only need to manage the application, data, runtime, the middleware, and the operating system. So you don't really need to manage the physical hardware. An example of an infrastructure as a service would be Compute Engine, Amazon EC2 instance, etc. As we further progressed, there was another change. The cloud service providers were ready to manage the runtime middleware and OS. So that leaves with you manage applications and data. From there, PaaS or platform as a service came into existence. So you only have to manage your application and data. You don't need to worry about the infrastructure. An example of PaaS would be App Engine. At last, we had SaaS or software as a service. Here, you are the end user of the application. What you're provided is an entire application which is managed by the cloud service provider itself. Most of you encounter these SaaS applications on a daily basis. The examples being Google Workspace, which involves Gmail, Meet, Google Drive, etc. Now let's look into what services a cloud provides. It can basically be categorized into four. One is networking, second is compute, third is storage, and fourth is specialized services like AI or machine learning. Let's take a look into the networking. When you work in the cloud, you need to work with networking between your resources and the hardware. For example, consider that you have several virtual machines running in your environment, and definitely you will have to manage the IP addresses at some point. So each device or any service will need an IP address. Within GCP, you can have both internal and external IP address. So internal address is only accessible within the GCP network. So this internal GCP network is known as Virtual Private Cloud or VPC. A virtual private cloud is an internal GCP network and it has internal and external IP addresses. And external IP addresses is what you can access from the internet. Another thing to note is that external IP addresses can be static or ephemeral. So, static means it is assigned to that device or that service for a particular period of time. Ephemeral IP addresses are subjected to change whenever the service is stopped. For example, you have an ephemeral address attached to a VM. If you stop the VM and if you restart it, you will lose that IP address and a new IP address will be assigned. In addition, you also need to have some firewall rules in order to control the access to the networks. For example, let's say you have a database server and you want to restrict the access so that the application can only query it. So, what do? You configure a firewall rule which will limit the inbound and outbound traffic to the IP address of that particular application which is running on a server or a load balancer which is in front of that application. Sometimes you might need to share the data and network access between a data center and your VPC. So, in those cases, you use something called peering. So, in peering, you connect between VPCs. And for that, you can also use something like a virtual private network or VPN. So a VPN connects networks to the VPC through an IPsec. Now, let's talk about the compute resources. Virtual machines. It is the fundamental unit of computing. To create a virtual machine, you can use either the console or the cloud shell. And the virtual machines correspond to a physical server. So that is equivalent to a virtual server. If you create a virtual machine, you have already a server assigned. And once a virtual machine is created, you can log in and you can perform the operations just like how you do on a server. We also need to consider multiple virtual machines. So now we just talked about a single virtual machine. What if there are more than one virtual machine? In those cases, to manage them, we use load balancers and autoscalers. We consider it as a group, more like an instance group, so that we can consider each of these instances within that group. So whatever changes is applied to that group will be applied to each individual virtual machine. And to direct the traffic, what we do is use a load balancer. So a load balancer gets directed the traffic to the instance group where each of the instance can be accessed based on the demand. We use autoscalers so that if the number of instance is not enough, it can be scaled. If we are going for autoscaling, we can set some parameters and some threshold values, after which if it exceeds, the system will automatically scale. And these instance group can also be containerized into a cluster. What is containerization? When we talk about virtual machines, what happens? You might be feeling easy to manage 5 instances, but at the same time, what if you have to manage 1,000 servers? In those cases, you have to use something like containers. So a container is basically a total package with all its dependencies. One of the example is on your daily life is a laptop. Consider that you have a PC. It has a CPU, it has a mouse, it has a monitor, it has a keyboard. Consider your laptop. It has everything packaged into a single unit. So this laptop can be mapped as containers. Whatever happens inside that container will be restricted within that container. For the clusters, GCP uses containers, or also known as lightweight virtual machines, and it automatically does a health check where it checks the health of the clusters, and then if it fails, another cluster will be started. This is one of the best options for microservices. If you're working with microservices applications, you can put one container for, or at least more than one container, each for each of the features. So even if some containers fail, only some features will be down rather than the entire application. We talked about managing those virtual machines. Managing those virtual machines or containerization requires some level of effort to administer or configure. Let's say a company doesn't have much people resource to manage these infrastructure. In those cases, serverless is the best fit. Serverless computing is something like an approach that will allow developers or application administrators to run their code in an environment where they don't really have to set up these virtual machines or clusters. Google Cloud Platform now has three types of services within the serverless: App Engine, Cloud Functions, and Cloud Run. If you want to run a website, including its backend, you can use App Engine. If you want to do some specific events like reading or writing, use Cloud Functions. If you want to host a static website, you can use Cloud Run. One of the most advantage for Cloud Function is that it is the best fit for short events. You can also alternatively use Cloud Run, but Cloud Functions and Cloud Run are both the services that provides best fit for short-lived events. As we talked about computing, now let's talk about storage. In cloud, there are four types of storages available. These are object, block, file, and cache. If we look into the enterprise users, they will use probably a combination of these services. Object storage is a system that manages the use of storaging as blobs or objects. So whatever object you store will be called as a blob or an object. And it is collectively stored inside a bucket. So these objects are grouped into buckets. Similar example could be a folder under which you are storing those files. So each object is individually addressable by a URL. So you can access it using its own URL. And cloud storage is a serverless service, so you don't really manage the infrastructure. So you don't need to create any virtual machines or attach any storages to them. The object storage provided by Google Cloud is cloud storage. So the next one is block storage. So block storage uses fixed size data structures called blocks in order to organize those data. It is commonly used in persistent disks attached to virtual machines. So with a block storage system, you can actually install these file systems on top of the block storage, or perhaps you can also run applications that access these blocks directly. So block storage is available on disk, which is attached to persistent disk or ephemeral disk, which is attached to the VMs. So it can be either ephemeral or persistent. A persistent disk continues to exist and store data even if it is detached from a virtual server. Ephemeral disk exists and store data as long as the VM is running. So if you shut down the VM, the data will be lost. Persistent disks are used when you want the data to be accessed on a block storage independent of a virtual machine. And these are good options when you have data which is available even after the life cycle of a virtual machine. It also supports fast operating system and file level access. As we talked about block storage, now let's talk about the file storage. So file storage provides a hierarchical storage system for the files. Google Cloud has Cloud File Store, which is based on network file system. These file storages are independent of virtual machines, and it is suitable for the application which requires operating system like file access to the files. So the file storage system decouples the file system from specific virtual machines, and the file system, its directories or its files is independent of the virtual machine, and any application can access those files. Next one is cache. Cache is an in-memory data store which has faster access to the data. So the time taken for the data to be retrieved is called the latency. Why do we need cache? Because it reduces the latency. But at the same time, we should not save our data entirely on cache. Why? Because one is the expense of the SSDs and HDDs. It will be on a long term very costly if we decide to store the data on a cache. Also, the cache is volatile, so whenever it is switched off, we lose the data. And caches can also get out of sync with the system of truth. So if the system of truth is updated but the new data is not written, this would happen. Next one is specialized services. One of the most key attractions of these specialized services is that it is serverless. Whatever specialized services you're using it for a particular use case. It provides an application programming interface or APIs to access the functionality of that service. And based on your usage, you will be charged. So for GCP, there are several services provided. Some of them are AutoML for machine learning without coding, Cloud Vision Cloud Natural Language for natural language processing, and Cloud Inference API for time series data correlations. So these specialized services are used to encapsulate those advanced computing capabilities and make them accessible to those developers who are not experts in any domain. Another important topic is cloud versus on premises. The reason is that although you might have seen that running a virtual machine is nothing but running a physical server, but it has some differences. And let's take a look into the differences between cloud and on premises. In cloud, you rent resources instead of owning it. So, when you need a particular resource, you don't need to buy it, but you just rent it. And once your need is done, you give it back and you pay for what you used. But on premises, you need your own resources and you have to buy the resource if you want to start using. For cloud, you can pay as you go. So, for the time you are using the resource, you are only paying it. But for on premises, you need both capital expenditure, which is capex, and operational expenditure, which is opex. So you initially need a capital expenditure in order to buy those resources. On cloud, you will reduce the capex and you will only have the opex. For cloud, you can have flexible resource allocation. When you need more resources, you can quickly rent out the resource from the cloud providers. But for on premises, the process is hectic. On cloud, you will also have some specialized services, but on premises, you don't really have. Let's now take a look into the services which Google Cloud Platform provides. There are a few topics which we can categorize these services into. One of the most important being networking. So we'll start with the introduction to networking. Google Cloud Platform actually provides a number of networking services which will allow users to configure virtual networks within the Google's infrastructure. Let's say an enterprise is operating its own data center or the on-premise. It controls what is physically located in that particular on-premise environment. Its infrastructure is physically isolated from other organizations who are having their own data centers. When an organization moves into a public cloud, what actually happens is that it will share the infrastructure with other customers of that public cloud. In this case, even though different enterprises use the same infrastructure, they can logically isolate their resources by creating a virtual private cloud or VPC. So, one of the most unique feature of GCP is that VPC can be panned across the globe without relying on public internet. So, let's say the traffic from any server on a VPC can be securely routed through the Google's global network to any other point on that network. One of the other advantage of the Google's network structure is that your backend servers can access Google services like machine learning services or IoT services without creating a public IP address for those backend servers. We can also link Google Cloud's virtual private cloud to on-premise virtual private networks using the IPsec protocol. Even though VPC is a global resource, companies can use separate projects and billing accounts to manage different departments within the organization. The next one is Cloud VPN. Cloud VPN is a Google Cloud Platform's service which can securely connect your peer network to your VPC. The connection happens through an IPsec or Internet Protocol Security VPN connection. So when you connect a VPN between two networks, the traffic traveling between the two networks is encrypted from the first VPN gateway, and when it reaches its destination, it gets decrypted by the other VPN gateway. So the data traveling throughout the cloud VPN will be secure and encrypted. So this actually protects the data when it is traveling over the internet. And you can also connect two instances of cloud VPN to each other. Next is one of the most important topics, cloud load balancing. Google provides global load balancing to distribute workloads across your cloud infrastructure. Using a single multicast IP address, it can distribute the workload within and across regions and autoscale resources to adapt changes in workload. It also supports internal load balancing, so no IP address need to be exposed to the internet to get the advantages of load balancing. And cloud load balancing is a service which can actually give load balancing towards HTTP, HTTPS, TCP or SSL, and UDP traffic. Cloud DNS is a domain naming service provided on GCP. It is a highly available low latency service for mapping domain names to their IP address. Cloud DNS is designed in a way that it automatically scales so that customers can have millions of addresses without the concern of scaling the underlying infrastructure. It also provides for private zones, thus allowing creation for custom names for your virtual machines. CDNs are very important. CDN stands for Content Delivery Network. So, with these content delivery networks, users from anywhere can request a content from the system distributed across various regions. So, Cloud CDN enables low latency response to these requests by caching contents on a set of endpoints across the globe. Cloud CDN is a managed service, so there is no need to maintain region specific configurations. Cloud CDN is especially important for websites with large amount of static content and a global audience. One of the example could be a news website. They could actually use Cloud CDN so that they can cache the content, and whenever people are loading the website, it will immediately serve the content. When we expose services to the internet, it could potentially become an target for attack. So there are different kind of attacks. Perhaps most of you might know about the distributed denial of service, otherwise known as DDoS attacks. So in DDoS attack, once it happens, you won't be able to access the application. So to avoid this, Google Cloud has a service called Cloud Armor. So it is a network security service which is built on Google Cloud's HTTPS global load balancing. So some of the features of Cloud Armor is that it has the ability to allow or restrict access based on the IP address. It has predefined rules to counter cross-site scripting attacks. It also has the ability to counter SQL injection attacks, to define the rules both at L3 and L7 layers, which is networking layer and application layer. It also allows and restricts access based on geolocation of the incoming traffic. So if you want to block any regions, you can use Cloud Armor. Google Cloud has Cloud Interconnect for connecting your network to the Google Cloud's network. It actually provides two types of connections. One is interconnect and the other is peering. So the interconnect with direct access to networks use address allocation for private internet standard, also known as RFC 1918, to connect to devices on your VPC. A direct network connection is maintained between an on-premise or a data center and one of Google's co-location facility in any of the continent. If Any enterprise cannot achieve a direct interconnect with a Google facility. They can also use partner interconnect. So this service is actually dependent on a third party network provider to provide this connectivity between the company's data center and a Google's facility. And for companies that do not require the bandwidth of a direct or peered interconnect, Google offers VPN services. So Cloud VPN can be used if you don't require the bandwidth for a direct or peered interconnect. Let's talk about introduction to compute services. Public cloud services provide a range of options on computing. On one end, we can say customers can create and manage virtual machines by themselves. So this model actually provides a way for giving the control to the user. So users can choose the operating system, what packages need to be installed, when do they want to do a backup or either perform any maintenance. So this is basically referred to as infrastructure as a service. Google Cloud also has platform as a service, which provides them a runtime environment to execute those applications without managing these infrastructure. So Google Cloud's infrastructure as a service products are something like Compute Engine, which I mentioned earlier, and the PaaS or platform as a service offerings being App Engine, Cloud Functions, etc. So Google also has Google Kubernetes Engine, which can manage containers. Now let's take a look into each of these. Compute Engine. It is a service that allows users to create virtual machines, attach storage to those virtual machines, and use other GCP services. Let's say an example, cloud storage. So VMs are basically an abstraction of a physical server. So it's like they're programs that emulate physical servers and provide CPU, memory, storage, etc. So virtual machines run within a low-level service called a hypervisor. For GCP, it uses a security-hardened version of KVM hypervisor. So KVM stands for kernel virtual machine, and it provides the virtualization on Linux systems. So hypervisors run on an operating system like Linux or Windows, and it can run multiple operating systems, which is also known as guest OS. And each instance of an executing guest OS is a VM instance. To talk more about virtual machines, it has a variety of sizes, but you can also create customized configurations. When you create an instance, you have to specify a number of parameters, including operating system, size of the persistent disk, if you want to add graphical processing unit or GPU for intensive compute operations, for example, machine learning. And you can also make the VMs to be preemptible. Preemptible virtual machines are something which you should always keep in your mind. Using a virtual machine can be costly, but if you use preemptible virtual machine, you will be charged very less, around 80% less cost. But there is another limitation to preemptible VMs. It will only run for at most 24 hours. So it could, once it has run over 24 hours, it could be shut down anytime. And preemptible virtual machines are basically used or typically used for running batch workloads. Next one is Kubernetes Engine. Kubernetes Engine is designed in a way to allow users to easily run containerized applications on a cluster of servers. So these containers are compared to virtual machines because they're each used for isolating the computing, processing, and resources. So, containers actually take a different approach than the virtual machines for isolating the process. Like I mentioned earlier, a VM runs guest OS on a physical server. The physical server runs an OS as well, along with the hypervisor. A different approach is to isolate these computing resource is to use features of the host OS to isolate the process and resource. So in this approach, you won't need to manage any hypervisor. What happens is the host OS will maintain the isolation. Instead of the hypervisor, we use a container manager, which is a single container manager coordinates containers running on that server. So no additional or guest operating system runs on top of the container manager. Containers also make use of the host operating system functionality, while the OS and container manager ensure isolation between the running containers. This is a logical representation of containers. If you take a look over here, you have three containers within the cluster. So this one is a cluster which has an infrastructure and it has a host operating system and it has a container engine which manages those containers, and each container is running each application, app 1, app 2 and app 3. Google Kubernetes Engine is a GCP service which allows users to describe the compute, storage, and memory resources required to run their services and then provision the underlying resources. It is very easy to add and remove resource from a Kubernetes cluster using a command line interface or a graphical user interface. In addition, Kubernetes also monitors the health of servers in the cluster and it automatically repairs failed servers. It also supports auto scaling so that if the load is increasing, additional resources are allocated. Next one is App Engine. App Engine is GCP's platform as a service offering. Using App Engine, developers and application admins don't really have to concern about configuring a virtual machine or creating a cluster. You can create applications and deploy on serverless environments. App Engine manages the infrastructure and it is managed by Google. So you don't need to manage anything regarding the infrastructure. It is one of the best options for mobile or web applications. It supports different languages like Node.js, Python, Java, and Go. So if you have any applications which is built on these languages, App Engine would be a good choice. It is also available on two types, standard and flexible environments. In the standard App Engine environment, you can run applications on your language specific sandbox. And it's a best fit for language specific applications that do not require operating system packages. The next one is App Engine Flexible. So in the flexible environment, you are running Docker containers. It is one of the best use case for running any application that requires libraries or third-party softwares installed. Just like the name, it gives you more options, including the ability to work with background process and writing to a local disk. Next one is Cloud Functions. Cloud Functions is very much suited for event-driven processing. It is a lightweight service which runs code in response to an event, like a file uploaded to a cloud storage or a message sent to a queue. One of the most important things is that the code that executes in the cloud functions must be short running. So the maximum time limit for cloud functions is 9 minutes. So you can do any events which happens under that time frame. It is often used to call other services or third party application APIs or any other GCP services. Similar to App Engine, it is Cloud Functions is also a serverless product. So users only need to supply the code and they don't need to configure anything. It can automatically scale if the load is increasing. Next one is storage. So now as we talked about networking and compute, we will now talk about the storage services provided by Google Cloud. GCP has several storage resources for storing objects and files. Now let's take a look into each of those. Cloud storage is Google Cloud's object storage system. The objects can be of any type of file or a binary large object, and it is organized into buckets. It is not really attached to any virtual machines, so you can say that it is totally independent. Cloud storage is accessible from virtual machines or any devices with necessary privileges or permissions, and it can complement the file systems on persistent disk. One of the unique properties is that each stored object is uniquely addressable by a URL. So if you need to access any object, you have its own URL. Cloud storage is useful for storing objects which could be treated as a single unit of data. Let's say an example being an image. That could be a good candidate to be uploaded. There are different classes of cloud storage. The first two being regional and multi-regional. What are regions? They're geographical areas where it has multiple zones or deployment areas. So one zone is considered as a single failure domain. So let's say if all instances is running in a zone and there is a failure, then all those instances can't be accessed. So in those cases, you can use regional storage. So when you choose the regional storage, it stores the object in a single Google Cloud region. And in a single region, it is a distinct geographical area and it will have multiple zones, like around 3 zones. And it is also suited for applications running in the same region, and it needs to have low latency for accessing the objects. Let's say an application is restricted to a particular region. In those cases, you can use a regional storage because that will provide you the best low latency. In addition to these, you can also improve its availability and reliability using multi-regional storage. So when your application or data is distributed across different regions and you need to make minimum latency for those to access it, use multi-regional storage. You want to keep the data for a long period of time but less frequently accessed. In those cases, you can have nearline and cold line storage. If you want to rarely access, like once over a quarter, you can use nearline storage. And it actually costs less than regional or multi regional storage. And it is optimized for infrequent access of the data. Now, let's say you don't want to access the data every month. You only need to access or over a year. So in those cases, you can use cold line storage. So on cold line storage, it will have even higher durability and less cost, and you will not be accessing that data as frequent as the data you store in nearline storage. Google Cloud now also has archival storage, which can store data for a longer time, like 10 years and above. Another advantage for storage is that you can set lifecycle management policies which will manage the object based on the policies you are defining. So let's say you want to keep the data for a particular amount of time, you can set the lifecycle policies for that particular data, and it will be deleted after its lifecycle is completed. The next one is persistent disk. So persistent disk are storage service which is attached to the virtual machines, and it provides block storage on solid state drives or SSDs and HDDs. SSDs are often used for low latency application where the persistent disk performance is important. SSDs will cost more than HDDs, so applications that require large amount of persistent disk storage, but you can tolerate longer read or write time, then you can use HDDs to meet the storage requirements. One of the advantages of persistent disk on Google Cloud Platform is that these disks will support multiple readers without degradation in performance. This way allows multiple instances to read a single copy of data. The disk can also be resized as needed while in use without restarting the virtual machines. Also, the persistent disk can be up to 64 terabytes in size. Either you can use SSDs or HDDs. Next one is Firebase. The Firebase might be popular among mobile application developers because it's a combination of cloud storage and the ability to support uploads and downloads from mobile devices even in an unreliable network connection. The Firebase API is designed to provide a secure transmission as well as a robust recovery mechanism to handle problematic network quality. It also has the ability to support uploads and downloads from mobile devices. Files like photo or music are uploaded into cloud storage, and you can access those files through command line interface or SDKs. Sometimes developers need file system on the network attached storage. In these cases, Cloud File Store is helpful. It provides a shared file system for use with Compute Engine or Kubernetes Engine. It can provide a high number of input-output operation per second, also known as IOPS. It is implemented with the network file system protocols, so system administrators can easily mount shared file systems on virtual servers. So these storage systems are like used for coarse grained objects like files. But if the data is even finely structured, you need to use a database management system. For Google Cloud, there are multiple database options. Some are relational, some are NoSQL. Some are serverless, and others might need management. Some provide atomic transactions, and others are sometimes for applications with less consistency and transaction requirements. GCP users must understand the application requirement before you choose a service. And it is very important when you are choosing a database. First database service is Cloud SQL. So Cloud SQL is a GCP managed DB service which allows users to set up MySQL, PostgreSQL, or SQL Server databases. You don't really have to do any database administration task because it is a managed service. There are a few configurations which is available. The first one being the first generation MySQL database, which actually uses MySQL 5.5 or 5.6, and it has up to 16 GB of RAM and 500 GB of data storage. The second generation of MySQL database uses MySQL 5.6 or 5.7, and it can have up to 416 GB of RAM along with 10 terabytes of data. So, second generation databases can also be configured to automatically add storage as needed. There is also PostgreSQL running on the second generation platform. It uses PostgreSQL 9.6, and it can be configured with up to 64 CPUs, 416 GB of RAM, and up to 10 terabytes of storage. It also allows the management of replication and it also allows automatic failover. Thus, it provides a highly available database. And it is also well suited for applications with relatively consistent data structure requirements. For example, a banking database, which will definitely have some account numbers, customer names, address, and etc. So, since virtually all these records in the database will need the same information, this kind of application will be a good fit for a relational database. As we talked about Cloud SQL, it is a regional resource. So if you want to have multiple instances, you can only have instances on each region, and it is not global. When we want to use it globally, we use Cloud Spanner. So Cloud Spanner is a GCP service which is globally distributed. It combines with key benefits of these relational databases like consistency and transaction, also with the ability to scale horizontally like a NoSQL database. It is a highly available database with 99.999% availability of service level agreement or SLAs, and it makes a good option for enterprise applications which require scalable and highly available relational databases. It also has enterprise grade security with encryption at rest and encryption in transit, along with identity based access controls. And Cloud Spanner also supports ANSI 2011 standard SQL. Next one is Cloud Data Store. Cloud Data Store is a NoSQL document database. These kind of databases use concept of a document or collection of key value pairs as the basic building block. And the documents will allow for flexible schema. It is helpful when the applications must accommodate a range of attributes, some of which may not be known at the time of designing. Cloud Data Store can be accessed through REST API, which can be used from the applications running on any of the servers or GCP services. This database will also scale automatically based on its load, and it can also shard or partition data as needed to maintain the performance. Since the Cloud Data Store is a managed service, it cares the replication, backups, and other administration DB tasks. Even though it is a NoSQL database, it also supports transactions, indexes, and SQL-like queries. It is also well suited for applications that demand high scalability and structured data and do not always need strong consistency when reading the data. Some of the examples are product catalogs or user profiles or perhaps user navigation histories. The next service is Cloud Firestore. Cloud Firestore is a GCP managed NoSQL database service designed as a backend for highly scalable and web mobile applications. One of the unique features of Cloud Firestore is its client libraries, which provide offline support, synchronization, and other features for managing the data across mobile devices, IoT devices, and backend data stores. For example, we can say applications on mobile devices can be updated on real time as the data in the backend changes. It also has a data store mode which enables application written for data store to work with Firebase. It also provides real-time data synchronization and offline support in native mode. Next one is Cloud Bigtable. Cloud Bigtable is designed for petabyte scale applications that can manage up to billions of rows and thousands of columns. It is based on NoSQL model known as wide column data model, and unlike Cloud SQL that supports relational databases, it is suited for applications that require low latency write and read operations, and it is also designed to support millions of operations per second. It also integrates with other Google Cloud services like Cloud Storage, PubSub, Dataflow, etc. It supports the HBase API, which is an API for data access in the Hadoop ecosystem. It also integrates with open source tools for data processing, graph analysis, and time series analysis. The last one on the database service is Cloud Memory Store. The Cloud Memory Store is an in memory cache service. Other database services are offered on GCP are designed to store large volumes of data and support complex queries. But Cloud Memory Store is a managed read service for caching frequently used data in memory. These are used to reduce the time needed to read data into an application. And Cloud Memory Store is designed to provide sub millisecond access to data. Even though it's a managed service that allows users to specify the cache size, leaving the administration task to Google. GCP also ensures that high available patching and automatic failover is available for Cloud Memory Store so that you don't have to worry about it. Next one for the data management is Cloud Dataproc. Cloud Dataproc is a highly scalable managed service for running Apache Spark. So you can create clusters quickly and then manage them easily. If you want to run a Spark workload, you can use Cloud Dataproc. It is a tool for batch processing, querying, streaming, and machine learning. Some of the advantages of Cloud Dataproc is that it is low cost, integrated, super fast, and managed. The next one is Cloud Dataflow. Cloud Dataflow is a fully managed data processing service. It is a way to enable fast, simplified streaming data pipeline development with low data latency. One of the advantages of data flow is that it simplifies operations and management. In order to maximize the resource utilization, you can use horizontal autoscaling of the worker resources. It is mainly used for data processing pipelines. The next one is Cloud Data Fusion. Cloud Data Fusion is built on a scalable distributed data lake on Google Cloud by integrating data from siloed on-premises platform. It increases the process visibility, lowers the overall cost of operational support, and it is fully managed. It is a code-free graphical interface where you can interact with it. Some of the use cases for Cloud Data Fusion would be modern, secure data lakes on Google Cloud or agile data warehouses with BigQuery. Another service is Cloud Data Catalog. It is a fully managed and scalable metadata management service. It is very easy to use search interface for data discovery. It allows the organization to quickly discover, manage, and understand all the data in Google Cloud. Some of the use cases could be searching for insightful data, understanding data, or making data useful. Suppose you want to run Apache Airflow workloads. You can use Cloud Composer. Cloud Composer is a fully managed workflow orchestration service built on Apache Airflow. You can author, schedule, and monitor the pipelines that span across hybrid and multi cloud environments. It is very easy to use, and some of the key features are it supports hybrid and multi cloud. It is open source based and you can easily orchestrate it. As we talked about the core services of Google Cloud, now let's see what are the additional components which is provided on Google Cloud. Let's take a look into the management tools provided by Google. So Google acquired Stackdriver, which is a service that collects metrics, logs, and event data from applications and infrastructure. It integrates the data for DevOps engineers to monitor, assess, and diagnose operational problems. For monitoring, Google has Cloud Monitoring, which extends the capabilities of Stackdriver by collecting the performance data from cloud resources and application instrumentation. You can use Cloud Logging, where it enables users to store and analyze and alert on log data from the cloud logs. Google has Cloud Error Reporting, where it aggregates the application's crash information for display in a centralized interface. Google Cloud also has Cloud Trace, which is a distributed tracing service that captures latency about an application to help identify the problem areas. It also has Debugger, which enables developers to inspect the state of executing the code, inject any commands, and view call stack variables. It also provides Profiler, which collects CPU and memory utilization information across the call hierarchy of an application. Let's also take a look into the specialized services provided on Google Cloud. One of the biggest specialized services that stands apart Google from the other cloud providers is APG API platform. It is a management service providing the API access to their applications. It allows a way for developers to deploy, monitor, and secure their APIs. It generates API proxies based on the open API specifications. And the APIs from the APG API platform can be authenticated either using OAuth 2.0 or SAML. And whatever data passing through the API is encrypted both from REST and transit. Some of the other specialized service is BigQuery, which is a petabyte scale analytic database services for data warehousing. If you want to use Cloud Data Flow, it is a framework for defining batch and stream processing pipelines. Or if you want to have a managed Hadoop or Spark service, use Cloud Data Proc. And Google Cloud also has Cloud Data Prep, which is a service that allows analysts to explore and prepare data for analysis. Google Cloud also has Cloud AutoML, which is a tool that allows developers without machine learning experience to develop machine learning models. It also has Cloud Machine Learning Engine, which is a platform for building and deploying scalable machine learning systems to production. If you want to choose natural language processing tools, you can have Cloud Natural Language Processing, which can be used for analyzing human languages or extracting information from any text. Google Cloud also has Cloud Vision, which is an image analysis platform to classify images with metadata, extract text, or filter content.